Hey guys, welcome to DSA-n-Design. Today we will look at one of the important design related problem and we will be using stack to solve this particular problem, right? So let's try to understand first what is the problem, right? So this is basically a design problem, right? And let's try to understand first. What we want to do is we want to basically use order of one time complexity, right, to solve few of the operations that we actually use in stack, right? So one is push operation, right? Push X, let's say one element, pop element, pop and top, and then also the minimum of the stack. All right. So these are the four functions that we have to basically design, and all of them should be functioning in order of one basically, right? When we actually use them, right? So we know that we can actually use stack data structure here, right, to do push, pop, and top, all of them, right? Because we can, these are basically ready-made functions within our kind of stack data structure, right? But the real problem here is with the min, right? So how do we get minimum in order of n, order of 1, right? So for example, let's say we have something like this. We have a stack. For example, we have 2, 5, 8, right? Something like that. If I need to get the minimum, right? Minimum is 2 here. I have to basically use order of n operation, right? Because I have to pop literally each of them, then only I can actually access this particular element, right? Because in stack we actually follow the LIFO, right? Last in first out. So this we have to pop out first, then this, and then this one. So this is clearly not possible with order of 1, right? Which means what we have to do, we have to actually for these three functions, they are pretty much straightforward. We can use exactly the stack data structure to do this, but min is something that we have to actually think about it. How do we actually solve this, right? So let's try to understand first, right? So let's try to see normal kind of approach, right? And see whether the approach is fitting, right? So for example, let's say I want to actually store something in maybe uh, basically a variable called min, right? I can use some variable min, and what I can do is I can store the minimum value possible, correct? So for example, let's say I stored, the moment I get this value, I'll be pushing these elements, let's say in this, and then I have 10 and I have, let's say 3 or something like that, right? Uh, or maybe not 3, maybe 1. Correct. In this case, guys, let's try to understand first, okay? So first, let's say these are my push operation. All of them are my push actually. So I want to actually insert all of them. So I will actually put 2 and 5, and minimum will be basically the minimum. So for example, first time my minimum is going to be 2, and then until I get minimum, I'll not be actually updating this value in this variable, right? So here also not updating, here also not updating, here also, but the moment I got 1 in my stack, I'll be updating it 1, correct? Now let's say there are certain pop operation, right? So let's say I am going to do two pop operation, right? In that case, I'll be actually popping out this one, and then I will be actually, so my minimum is still 1. This time my minimum is 1. After popping 1, popping out, after first pop out, right? If I want to check what is my, the minimum value, right, among this. So we still get like 1 actually here, right? Which is not correct, correct? In this case, my minimum is 2, right? Which means I have no way to maintain this basically. Or even if you say that, okay, if I'm popping out 1, then I'll be updating some value. For example, the previous was like 2, then I cannot actually update that also because I lose this value, right? If because my variable can only store only one single value, right? So now in this case, what I can think about is, let's try to maintain some sort of kind of another stack, right? And where I will be storing all the minimum values, right? So for example, let's say, so the idea one is not working here, right? So let's say I have idea 2. Okay, I'll be taking this very same value, right? So what I'm going to do, I'm going to insert 2, 10, 8, sorry, 2, let's take some other example. For example, guys, let's try to take here 20, 8, 12, 15, 5, 9, and maybe 25 maybe. All right. These are my values. For example, I'll be taking one normal stack, right? This is my normal stack. So this normal stack, I'm going to perform these operations like push operation, pop operation, top operation, and all those, right? Right? Now, for minimum, I'll be maintaining another stack here. Maybe I'll call this as a minimum stack. Minimum stack, okay? And this one I'll call it as a value stack. Let's see what is the use right here. So minimum stack, let's say uh, here I am going to put 20 by default first, and here also I'll be putting 20 because there is nothing minimum, no? So first time I am putting it here, basically 20. Now second time what I'm going to do is I'm going to just check the this value, right? So my value stack will be containing all the values. So I'll be entering 8. But the moment I see here the smaller value, what I will do, I'll actually insert 8 as well here, because this 8 is lesser than 20, right? Which means I'm actually storing my minimum value on the top of it, right? So yeah, and then 12 actually. So my value stack will be putting all the values, so 12 here. Now I check whether my top of this minimum stack is less than 12. No, it is not. Sorry, it's greater than 12. No, it's not greater. Then I'll not insert it. Now I'll go to 15. 15 here. So anyways, I'll put it. Now I'll compare whether 15 is less than 8. No, it's not 8. I'll not do anything. Now 5. I will insert it here by default. But 5, I'll check whether 5 is less than 8. Yes, it is less than 8. So I'll actually put it here. Which means till now my minimum is 5. Correct? Now again, I'll go to 9. 9 here anyways it will come by default. But now I'll compare with 5. It is still bigger, so I'll not do anything. Now 25 here, right? 25. Again, 25 is bigger than this. I'll not do anything. That this point of time, can you tell me whether my minimum is the top of this element, minimum value stack? Yes, right? This is still valid, correct? Now, let's try to see the scenarios. So, for example, let's say I perform some pop operation. So, I'll performing first pop operation, this one, and I will check what is my minimum still in this particular stack. So my stack is still this stack I will check, right? So minimum 5 is still valid basically, right? I'll not do anything. If I pop the second element, again I will check whether this particular value is available in my minimum stack or not. If it's not, I'll not do anything. Now I'll check 5 actually. I am doing the third pop operation. This is pop 1, pop 2 and pop 3. Pop 3, the moment I say pop out this 5 value, right? That point of time, I find that my minimum stack is also having top element as 5 basically. Correct. In this case, what I will do, I will basically pop out this as well. Okay. Correct. Now I will check what is my minimum value in this stack. So in this stack 5 is gone. So in this stack I can see still it is 8 actually. It is 8 actually, right? 8. But in this stack I will check what is my top. Then I find it's 8 because 5 is already popped out. And this is still valid, guys, right? This is what was the problem with the variable, using a single variable. But using the minimum stack I am able to know that. Now let's say I actually you know I found this one, right? Now I'll pop out 15. I do not see any 15 here. 12, 12 also popped out. Now the moment it come to 8, I popped out here. I checked my top is also 8 basically. So I'll also remove this. Correct? Now this is my stack. Now I have only 20 value, right? Value 20, and I'll check what is my top of this value stack. So it's 20, and I'll check what is my top of it. I'll get it here also, same thing, right? So always when I need to check the minimum stack, like the minimum value of the stack, I'll go to this particular stack, and for other three operations I'll be using this stack, right? So hopefully this is clear, right? Now this is the logic, guys. All right. What I will do is I'll try to show you a little bit of code, like how we can actually write the code for this, and then I'll show you how in ID, right? IntelliJ, right? Probably let's try to actually see this, right? How we can write these functions, different functions, right? So first of all, what we have to do, we have to write a four different functions, right? Can I make a class, for example, minimum, not minimum, I'll say design stack operation. Correct. Let's say my this is my what? This is my class, right? Now I will write three different function. One is basically void push, right? This is my push, and this will actually take int x maybe, right? I'll put some logic here, and then another one is kind of void pop. This is nothing, right? And maybe I can just write it here. I'll write something. Okay, now void pop, and then I'll say void, not void maybe. I'll write int, right? This is int. I want to get the top of the element, right? So this is the one, and then one more int minimum value, right? So what is the minimum of the stack at that particular point of time, right? So for example, when I am actually pushing a value in the stack, right? So what I will do before that, I'll create two stacks here, right? One is basically value stack, right? And second one is basically minimum stack, correct? Mini stack, something like this, right? I'll create two stack first here, and then what I will do first, because I don't have any control over the operation, right? So any operation can happen, right? So we have to actually handle the edge cases also, right? The corner cases, guys, right? So for example, the thing is, if there is there is no value in the value stack, right? In that case, what I will check is I will check if my value stack, right? Value stack is empty, right? If it is empty, in that case, which means there is no value at all. This is the first element, right? In this case, what I will do, I will simply add value stack dot push, right? This is my stack, no? So I can very much use these functions, right? Push operation, push and value of x, let's say, and then similar thing, I'll say mini stack dot push and x, something like that I can use, correct? All right, and I think it's too small, guys. I think probably let me, okay, fine. Let me write a little bit of better format, right? So let me write first push, yeah. So I think it will be better. So I'll say void push, basically push int x, for example, right? What I will say, if my value stack, val stack is empty, correct? If this is empty, then what I'm going to do, I'm going to just say that value stack dot push stack, right, dot push of x, correct? And then also what is that, minimum stack, no? So mini stack dot push, which means if my stack is empty, I think this is the first time I'm actually kind of visiting this stack. I'm inserting something. I will better stack push both the value in the both the stack, right? First time, right? If this is not the case, let's say I already have some value, right? So let's say this is my value stack, and this is my value stack, and this is my minimum stack. I don't have, in this case, anyways, I have to insert first time anything, everything, right? So both the stack I'm pushing. But in the second time, right? So what I have to do here, anyways, I have to, in the value stack, I will be pushing anyways, right? Because this is by default, all the values I have to put. But in case of mini stack, no, what I'm going to say, I'm going to compare whether my value in the stack. So what I'm going to say, I'm going to say if mini dot what I will say, peak, no, peak, which will give me the top of the element, right? If this is equal to what? If this is equal to x, correct? If this is equal to x, then no. If this is not equal to x, guys, if this is great mini, yes. If yes, correct. If my x is smaller, no, in that case, if my x is smaller, the value which is coming, no, here, for example, That's what we discussed, no? So let's say it was like 10 before. Here I inserted second time. This is talking about second time. So let's say I got 5, so I'll insert it here. But the moment I found that this 5 is smaller, then I have to insert it here as well, right? This is what we discussed, no? So in this case, if x is smaller than or equal to, both the cases are fine, right? Equal to also works. If that is the case, then I am going to insert into mini stack only. Okay, mini stack dot push, correct? Push of x. That's it, guys. This is about the push operation, correct? These are the push operation. Similarly, what I'm going to do is I'm going to use the same kind of thing for the pop operation as well, right? So what exactly I'm going to write in the pop operation? I'm not going to write all these functions here, but I'll just tell you, right? So similar for the push, we have to write the pop operation also. In pop operation, the logic is basically here also pop is going to be void. So I'm going to say pop. There is nothing to pass here. What I'm going to say, I will check if my value, if my stack is empty or not. If my value stack is empty or not. If it is my value stack is empty, which means before inserting any value, if I have actually already inserted something, correct? I mean, before inserting value, if I'm trying to pop out, it doesn't have anything, right? Value stack doesn't have anything. So what it will give? It will give you return minus. So what I will say, value stack, right? Dot is empty. If it is empty, then what it going to? It is going to return. Okay, pop. Okay, going to return nothing. No, nothing, right? So let's see. I am not going to write anything, right? I will leave it blank. Else, right? Else, what I'm going to do? I'm going to just dealing with the pop operation, right? So what I'm going to do? I'm going to else me. What I'm going to do? I'm just going to return. Not return. Sorry, guys. Control Z. Okay, I'm going to do value stack dot pick. That's it. Not pick actually, pop. Pop, right? Because I just want to take out this value, right? So this is what the operation that I'm going to perform here, right? This is for the pop operation. And then similarly for the top operation. Top operation also I will check whether if there is any value. If there is no value, and then in the top I will return -1 or something like that. And there is something now for the min also, similarly for the min also I have to write the logic, right? Let's try to do one thing. I'm not going to explain each and everything here, okay? But what we can do is let's look at the code that I have written so that you will be better understand, right? What we have done, right? So I already have done it. I have I'll just show you and we'll dry run, then you will get the better idea here, right? So here is the code basically, okay? I don't want to make this video very long, okay? So you can actually refer this code anyways, right? And you can do it. So what we have done, we have actually created this particular class, right? And we have taken two functions here. We have created two functions. One function is value stack and second one is the minimum stack. Minimum stack is basically the second stack that we are talking where which will help me to get the perform the third operation, which is getting the minimum value, right, from the stack. Now for the push operation, what I have said is what we will check is whether it is empty stack or not. So if it is empty stack, then in the push I will be actually putting the value into uh, in the both the stack, okay? Value stack and minimum stack, fine. Now if else, what we will do is we will anyways push the element into value stack anytime, always, right? Additionally, I will for the value minimum stack, I will check whether my value is lesser. If my value is lesser than the peak of the element, like the top of my element, whatever value is there in my minimum stack, if it is lesser than that, I mean the value is lesser than that particular top element, then I'm going to push. Otherwise, I'm not going to do anything, right? So this is about the push operation, guys. Okay. Now let's see the pop operation. Pop operation, as I said, if my value stack is empty, if nothing is there, what I will do? So I will say that don't do anything, right? Not do nothing. Else, if there is some value, correct? If there is some value in the kind of in the value stack, then I will take out that value. Okay, I'll say value dot stack dot pop, and I'll store into some value, some variable, right? And then I will compare whether this particular value is there or not. If it is exactly equal to the top of the minimum stack element, in that case I will pop out from the minimum stack also. That's why we discussed, no? So we will take out this here, right? The top element, it's very straightforward. Top element is nothing, guys. If the size of the kind of stack, like if it is there is nothing inside my value stack, then what I will just return -1. Okay, else I will just return the peak of the value stack, right? This is what I'm going to get it. Now the last one, which was critical, and because of that only we created this second stack, right? Minimum stack. What I'm going to do, I'm going to check if my minimum stack is empty. If it is empty, then I will say return -1. Okay, if there is no value is there, right? Which means before even getting any value, any pushing any element in the stack, if I'm just saying pop, then it should actually return me -1. Else it should always give me the peak of the element. That's it, guys. And this is what exactly we want to get it. Let's try to run it and see that. Okay. What I'm going to do, guys, I'm going to so I have created this object. Now I will be doing some operations, right? All these functions I'm going to access. So I'm going to say let's insert some values, right? So let's say I'm going to insert 20, that example that we have taken. Now ds.push, what I'm going to do, 28. Let me copy paste, guys. All right, 28, 12, 15. All right. Now, one second. Why is this? Sorry, not pop, guys. This is push. Maybe it was because of. Okay, let's see. Push. Fine. 15. Then 5 and 15. 5, 9, and maybe 25. No? This is what we decided. Now, what I'm going to do, I'm interested to know the minimum element. In this case, we will try to dry run. Okay. So this is the last thing. Let me actually try to print this actually. So ds dot minimum is a function. What I should be getting here in this case, guys, okay, let's try to understand this. Okay, so let me go here and let me show you here first. Okay, so for example, what we have done is we have got what 28, 12, 15, 5, 9 and 25, right? These are the elements. Now this is my stack, correct? Now this is 28, 12, 15, 5, 9 and 25, correct? They're the element. Now at any point of time, if I say minimum, then I should be getting what? I should be getting 5, isn't it? This is what I am expecting. I should be getting 5 basically, right? Let's try to see after inserting. I am actually inserting everything, guys. Now I'm just getting, after this I want to get, and I should actually get what? I should get 5 actually in the output. Let's see if I'm getting. Okay. See, we are getting it right. Now let's see if I want to do at least some operation. Let's say 2 pop operation, and then I want to just get it. So ds dot pop, not push, pop. Now ds dot pop. Okay, let's see. This time also I should be getting only 5. Yeah, I mean, just see, this is also I'm getting it right. Now the moment, if I can say, so if you see it here, no, so this is basically the way it is stored, no. Now so what I did, I actually popped it, popped this, popped this. Let me pop 3 pops, right? 1, 2, 3. And after that, I want to check minimum, and my minimum should not be 5 anymore. My minimum should be 8 actually. Let's see. So let me put one more pop operation here. Okay. Probably this will tell me whether my code is working fine or not. Now, after this, after third pop, my minimum should settle to 8 actually. Is it working? Let's see. Sorry. So we got 8 basically, correct? Which is actually right. See, I did 1, 2, 3 pop, and then if I see from here onward, no, from here onward, here to here, what is the minimum? Basically, it's 8, no, not 15, not 12, not 20, right? So it's actually 8 in minimum in this stack, right? Which actually I am getting correctly with the help of this min stack, right? So if you look at this min stack, here in min function I'm only using min stack function actually, right? But if you see on other three operations that I'm going to do, I'm going to perform on the value stack all the time. You see, value stack only, right? That's why this value stack and min stack, I has to use this min stack to handle this particular case, right? So I hope that this is really making sense. And this is, I think, a very, very important, coding round DSA question, right? So I think that it might have given you a lot of good understanding, right? Um, we have actually coded it and I have shown you like how to do this step by step. I will suggest you guys actually do it once and try to do this kind of testing once, and let me know if you are facing any issues. I'll be there to help you, right? So please comment on this video, and first time if you are watching this video, guys, please subscribe and share with your friends, right? And we are going to bring some more good content here. And don't forget to watch the previous playlist on the link list. We have covered a lot of problems there as well, right? So I hope that that can be helpful for you, right? So that's all for this video. I'll see you soon with the next video, guys. Until then, happy learning. God bless you. Bye.